So we need to talk about the electronic structure of the atom. And what that means is we're talking about how the electrons are organized outside of the nucleus of the atom. So there's a lot of experiments throughout the history of chemistry that have gone to explaining how electrons are organized outside of the nucleus of the atom. But the upshot of those experiments is that electrons are confined to specific areas outside of the nucleus. All right. So it turns out that those areas that are occupied by electrons, now we refer to them as shells of electrons. It's a way that electrons are organized. And we number those shells from the closest to the nucleus and then increasing in number for farther and farther out. So if our nucleus is right here, then we could think of the shells of electrons as getting bigger and bigger and bigger as we go outside the nucleus. So the closer the shell is to the nucleus, like for example, shell 1 is closer to the nucleus than shell 2, so it's lower in energy than shell 2. So we go from lowest energy to higher and higher energy as we go farther and farther from the nucleus and get bigger in shell. And it turns out that because the shells get bigger and bigger as they go farther from the nucleus, they can actually hold more and more electrons too. So if we look at the first shell of electrons, the one that's closest to the nucleus in an element, that shell can hold only up to 2 electrons. The second shell can hold 8, the third shell can hold 18, and the fourth shell, wow, we really get a lot of increase in the number of electrons there. We go from 18 all the way to 32 electrons in the fourth shell. So it turns out that the other important thing is that as we go up in shell number, we also increase the number of parts of the shell. So the way that we organize electrons within shells is in these smaller parts called subshells. So each time we increase our number in terms of shell, we add one more subshell. So the first shell of electrons has only one subshell, an S subshell. Our second shell of electrons has 2 different kinds of subshells. We call them an S subshell and a P subshell. Remember, these subshells are literally just parts of a shell. So it's the same way as if we're thinking about how to organize a tackle box, we would think about drawers within a tackle box and then trays within that drawer. In the third shell, you guessed it, there are 3 subshells. It turns out we call those S, P, and D. And then in the fourth shell, there are 4 subshells, S, P, D, and F. So every time we add one more shell of electrons to an atom, that new shell has one more subshell than the previous shell. That's really important to remember. So we just talked about the fact that shells are divided into subshells, and the larger your shell is, the more subshells it has in it. And we can even divide those subshells into parts of a subshell that we call orbitals. So each orbital can hold up to 2 electrons in it. And if we look at the number of orbitals in each kind of subshell, it looks like when we go from an S subshell to a P subshell, we're adding 2 more orbitals. When we go from P to D, 2 more orbitals. From D to F, 2 more orbitals. So remember that an orbital can hold up to 2 electrons, which means an S subshell can hold 2 electrons. A P subshell has 3 orbitals, which means it can hold up to 6 electrons. A D subshell has 5 orbitals, which means a D subshell can hold up to 10 electrons. And an F subshell has 7 orbitals, which means it can hold up to 14 electrons. So let's take a look at the first 4 shells of electrons that you might fill for an atom on the periodic table. And within that first shell, just like I told you guys, there's only one kind of subshell, an S subshell. Within the second shell, there are 2 different kinds of subshells, an S subshell and a P subshell. Remember that this column is talking about orbitals, and because there are 3 different orbitals in a p subshell, that's why p is listed 3 times. But there are just 2 subshells in that second shell. There are 3 subshells in the third shell, an S, a P, and a D. And then in the fourth shell, there are S, P, D, and F subshells. And what we see here is all of those different orbitals that exist in that fourth shell. If 2 electrons go into each one of them, that's where we get a total of 32 electrons in that subshell. Now we're going to talk about the shapes of just a couple of different types of subshells. All right, so remember the S subshell only has 1 orbital, so if we're looking at the S orbital, that's the same as the whole S subshell because there's only 1 orbital there. And it turns out that S subshells are spherical. As a matter of fact, S is code for spherical. P subshells, note that there are 3 different p orbitals within a p subshell, and it turns out that those p orbitals, each of which can hold a pair of electrons, they each have sort of a dumbbelly shape. So you can see this sort of like big parts on the outside and then the narrow part in the middle. As a matter of fact, right at the center of that p orbital, there's what's called a node, so there's no space in there in the middle at all. If we put 3 of those p orbitals together, we get an entire p subshell, and that's what that looks like. So as you might expect, we've gone up a lot in complexity when we go from an S subshell to a p subshell. So on the next slide, we will not be drawing D and F subshells. They're just too complex to draw.